So, we're talking about an idea that I just suddenly had. I don't know if anyone has this idea, so I need to explore it. But my idea is about something that I call single dimensions. Single dimensions. And no, again, yeah. Angular dimensions. Angular dimensions, single dimensions, and angular dimensions. So let's start with single dimensions. By single dimensions, I'm not referring to just one dimension. I'm just referring as something that you may understand after I talk about it. So what I'm referring to single dimensions is like the first dimension, the second dimension, and the third dimension. Now, if you see it clearly here, wait. Angular, I'll name it better something better later. Okay, so that doesn't matter now. So the first dimension, line. Second dimension, well, wait. No, that doesn't work. Okay, so first dimension, second dimension, third dimension. I'm not a good artist. So, after that, what I call angular dimensions is you can make singular dimension. Okay, angular dimensions is like starting from the fourth dimension and goes on up to infinity. I don't know what the infinity dimension looks like, even it's probably something crazy. So I'm just saying it goes up to that because it does. Now, it's like this. If you add 3 dimensions to any one of these, if you add 3 dimensions, like the first dimension, 1 plus 3 equals to 4, right? So if that happens, let's see what the fourth dimension looks like. Okay, now I call this angular dimensions because at a certain point of time and in a certain angle, only in that way, it'll be like a line. Just the same for the second dimension. Added with 3, 2 plus 3, 3 plus 3 equals 5 and 6. Now, I don't want to draw this, but I'm just going to draw like the fourth dimension one. Boy, just wait. So this point is this point. This point is this point. What is this point? This point. And it's like that. So as you can see, from one point, I didn't draw this well, but if there were symmetrical cubes and the lines connected, as you can see, they would perfectly make a line. But at one angle, since these go inward and outward again. So at only one point, that's why I call it angular dimensions. And I call these 1, 2, and 3 dimensions singular dimensions, because this one, it doesn't move in such a way that it can change its shape from this line into something like that, looking like the third dimension. Like the fourth dimension at one point looks like the third dimension, but I don't want to discuss that. I just want it to be like completely different thing. So what I wanted to happen is make it at one point so it's like a line. In the same way, look, if you bring this one out and this one out, imagine there's some cubes here. It makes a square at one point because this goes inward here, outward there.
What do you mean inward and outward? Why would things go inward and outward?
The fourth dimension goes in, it goes out.
Why?
It goes in, it goes out.
You mean the fourth dimension is not a static dimension?
It's not a static dimension. It always keeps moving.
How do you know?
That's how it is.
How do you know?
That's the basis I'm using for this.
Yes, but how is the fourth dimension moving? I mean, why does it move?
Now that might be something I'll do later, but I just use these conditions. I just heard of this, okay?
Heard where?
I've heard from many sources, okay? I've seen lectures.
Okay.
The fourth dimension constantly moves.
Okay.
And I've seen it, okay? So
Do you think that's why Einstein said time is the fourth dimension? Because it keeps on moving?
I think Einstein said the fourth dimension is time only because we can't see any shadows, three-dimensional shadows.
Yeah, but it may be also true that time is always moving. That's why he said it's the fourth dimension.
That's another possibility, but I need to discover that later. Now let's talk about what we're talking about.
Okay.
By inward and outward, I mean like the fourth dimension goes so far. What the basis I'm using, the logic I'm using is the fourth dimension moves like this, like this, like this, like this, crazy all around, okay? So the fifth dimension is just like the fourth dimension. But imagine here, my joint, and this joint is also a cube, just like my two fists, okay? So this moves inward, this moves inward, while this moves this way to catch up to my joint and touch it. At one point, they all become a cube. But I don't want to focus on that. I want to focus on what I call angular dimensions, or these dimensions I'm calling angular, 4, 5, 6, and so continue. Okay, now let's go one step below. 1, 2, 3, 4. Okay, now just imagine this. I don't want to draw it anymore. This is gonna become a cube. This is at one point gonna become different and smaller sized cubes. Okay, a cube with cubed corners, they all vary in size. There's one bigger than all of them, and they keep decreasing in size. Okay?
But do you think this will also happen if you just project light on these cubes, like, starting with this, right? The 3 dimension, and then you added 1 dimension to it, and then you're imagining that they're moving in one direction because it's a 4th dimension.
Yeah.
And then you're projecting more from other points of the cube.
Yeah.
But then you think, I'm trying to get what you're trying to say. Are you saying that these are, when you're adding dimensions to dimensions, broadly speaking, they're making dimensions again, but maybe in a line, and then in a plane, and then in a cube?
They're in a hypercube.
Yeah, they're in a
Line, plane, volume, hypervolume.
You mean line, surface, volume, hypervolume. Okay. But why are you calling this single dimension?
Oh, I'm calling it single dimension because well, just look at it. I call the single dimensions. I explained it to you with the line. I'm doing it again if you didn't remember. So I said there's a line, okay? Now, in the fourth dimension, at one point is also a line. Let's say these are cubes, okay? That's the fourth dimension. These are cubes.
So they connect like in a line.
No, at one point they seem like they're a line.
Really?
Well, they seem like they're a line, yes, from an angle. Some.
Oh, from a different angle.
Yeah, from at one point they look like a line, but that line can't be seen as just one dimension. It can be seen as a three-dimensional object.
Then
and from an angle,
what you're saying, what you're
it
trying
can be seen as.
I think what you're
know-
trying to say is not really a line, it's linear.
Yes, it's linear.
Ah,
No, like
that's the term we're missing here. Not looks like a line, it's linear.
no. Yes, I know it's linear.
Yeah, that's why they discuss linear algebra. Now it makes sense. Even in linear algebra, when you have matrices with 9 dimensions, like the MIT professor was saying, right?
Can you just?
It's linear. Because you don't,
Does this-
you never have a circular. Do you have any circular here? See, you have a curve of dimension at some point.
But it can't happen like this. Do you know why?
Why?
Let's see. Let's say because the way it's supposed to happen is it should look like a three-dimensional rectangle. It's supposed to look like that. But you can also do it like this. You can also, let's see, these are two cubes. Okay, so let me just draw one cube here. Now, if you can take this point, and then at one point, all of the points connect and make like one very thin thread that at one point again goes back into a bunch of threads in another cube. It can also happen like that.
Maybe. And when you talk
Yes,
about thread, is that thread at one dimension?
That thread is just joints, just joining together. And yes, they are one dimension.
So, but they can only be in one dimension if they come out of one point. But if they all
If they
meet,
come out of one point,
But
they
they-
can all be together just a little bit thicker one dimension. Maybe even they can fit through this hole. That's all. Together.
have you heard about string theories?
Yes, I have.
Do you know what they are? Do you remember?
Not too much.
Okay, maybe string theory talks something very similar. I don't know.
Okay, maybe.
Maybe we gotta watch up string theories this time.
Okay. But for some reason, I've seen right now.
I think you're getting close to string theories because string theory, I think, goes up to 16 dimensions.
But I'm just in, the basic dimensions.
Yeah, but the way you're thinking about it sounds like
Well, it does continue to.
because in string
16
theories,
dimensions.
what I think I've seen in string theories is that it connects dimension to dimension with a string. And this almost sounds like that. And you never know, this could be really new, like you assumed. Or it might be the same, but explaining in a different way.
Okay, but weirdly enough, the same thing doesn't occur to the second dimension.
What do you mean?
Well, it doesn't occur, I'm trying to say, as from an angle, it looks like the second dimension. But if you see it from this angle, you can see it's a little high. That's why I say it's from angles, different angles. That's why I call it angular dimensions. By singular dimensions, I mean it doesn't change anywhere. It doesn't change like at all. In the way like these change, angular dimensions, you have to see them at a specific angle in another specific angle.
Mm-hmm.
Like you have to be in a specific angle, that has to be in a specific angle.
Yeah.
That's why I call it angular. But you don't have to be in
I'll give you a better name.
What?
Relative angular dimensions.
Yeah, that's good. But listen to me first. In the line, only you have to be an angle. In a square, you have to be an angle. You have to be in a perfect angle. In a cube, you have to be a perfect in a perfect angle. Those objects don't have to be in a perfect angle, because if you are at a point where this is a line and you're seeing this, these are just points that connect the line. Okay, these two fists of mine. Okay, just imagine a line between them. Now, if you see it from this way,
I see a dot.
yes, you only see a dot. But if I change it, you're gonna see a line,
Yeah.
right? So it depends on you.
Why not? Why me?
Why me?
You could change that too.
You could change that, yes.
So why is it only me?
It's either, okay? It's either. But in what I call, what you just said, relative angular dimension, I can say as we both have to change angles.
It's starting from fourth dimension.
Yes, starting from fourth dimension, continuing on. And
Is it because the fourth dimension keeps on moving?
what dimension keeps on moving? Yes, there's a possibility of that.
But then how do you feel? How do you feel that? For example, I mean, why don't you feel it about this first dimension, that both has to be in a specific angle, but you feel it about the fourth dimension? You
Oh,
said
just say, as well as this,